Hello everyone, my name is Ashwini Dashgupta. I'm a faculty at Cheenta. I wanted to talk to you a little bit about group theory. This video is intended for those students who have enrolled for the Cheenta Extended Program for ISI MMath TIFR entrance or CMI Masters entrance or Mathematics GRE or IIT JAM and so on, or if you have enrolled for the problem solving MasterClass, and that is also intended for all of those entrances. It's great to have you here. Today I would like to share with you my experience with group theory and how I visualize the subject. Group theory is very close to my heart. It was part of my PhD program. My thesis was on something related to group theory and topology. It's a beautiful area of mathematics called geometric group theory. You can definitely explore that in the internet. When I think about groups, I actually think about a geometric object. I could have said a combinatorial object, but really I'm thinking about a geometric object which looks like a graph. That is, there are several vertices and edges connecting those vertices. And that graph, with probably infinitely many vertices and edges, is what immediately clicks in my mind when I think about groups. Of course, groups have their own definition. You can explore that definition. It's there in every introductory book. But this geometric way of thinking about groups can be very effective. One way to geometrize a group is to use something called a Cayley graph. That is, a group is of course a set, so you take one vertex for every member of the set and then you plug in edges into those vertices, the collection of vertices, using the generating set for the group. So what is a generating set? Well, they are some group elements, probably 5, 10, finitely many group elements, which you can glue together, that is, you can multiply out together to create all the elements of the group. So the word generated should tell you what it means. Using those 5, 10, 20 finitely many elements of the group, you can actually create all the elements of the group. So what you do is you think of every member of the group as a vertex or a dot. Let's call G a member of the group. So you have a dot for it, and you have G times S. S is a generator. That is another dot. So you connect those two dots by an edge, because those two dots are one generator apart. G and GS, G times S, is one generator apart, those two elements, so you connect them by an edge. And you do this for all possible group elements and all generators and all pairs of groups and group generators and so on, group elements and group generator elements. And what you end up with is the Cayley graph. You can try drawing different Cayley graphs. We will of course discuss it in the main class, so you don't have to learn it from here, whatever little I told you. But Cayley graphs can be very fun to play with. You can identify subgroups, you can identify cosets. All the beautiful properties of group can be seen using a Cayley graph. So that's one of the ways of thinking geometrically about a group. And there is a very deep theorem in group theory that says that if a group acts in a nice way on a space, then it is sort of similar to the Cayley graph. So it's not a novel invention. The Cayley graph is not a novel invention. It's a very natural way of geometrically seeing a group. And that's because every time you have a nice group action on some space, that space should look very similar to the Cayley graph. So again, groups do not come alone. groups come with actions. So that's another part of the story. You think about the groups geometrically, that one part of the story, and you think about groups via group actions. That's another part of the story. So I'm really excited to share with you all of these ideas in our group theory related sessions, and maybe we can move very deep into this subject. Of course, we will be solving a lot of problems from the contests like TIFR entrance, mathematics subject GRE, IIT JAM, ISI MMath entrance, CMI MSc Math entrance, and so on. It will be very exciting. I'll see you in the classroom, and until then, why don't you read some introductory book on group theory. My favorite one is Contemporary Abstract Algebra by Gallian. I'll put the name of the book in the link in the description, so you can check that out. Okay. All right. Thank you for watching this video. I will see you in the class. Take care.